Good afternoon, class. We are looking at chapter 3, derivatives here, section 3.3, basic differentiation formulas. We've covered derivatives and rates of change, the derivative as a function, and now basic differentiation formulas. Reminding you of rise over run when 2 points are given. We can write it as delta y over delta x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or if you look at this one, f of x minus f of a over x minus b. Or this graph, f of a plus h minus f of a over h. This point b, f of b minus f of a over b minus a, they are all the same thing. As q moves towards p, gives rise to a tangent line. So the tangent line is the limiting position of the secant line pq as q approaches p. Slope of a tangent line, also known as instantaneous rate of change. Therefore, if we go with this one as q approaches p, if you go with this one as x approaches a, and with this one as h approaches 0, which we call them f prime of a. Various form of points. If we go with the point slope at this pair a comma f of a, the equation of a tangent line becomes y minus f of a equals f prime of a times x minus a. And again, you don't have to memorize it just fine. Just follow the point slope. Now, as we look at this one, generally speaking, the point is x. We move h to the right, becomes x plus h. And so this one, instead of a, we change it to x. And that's a general format, the differentiation operation, in this case, the process of taking the derivative by definition. And now, basic differentiation formulas, starting with the constant. The derivative of a constant is 0. One way to look at it, look at the horizontal line. Y equals a number, any number. Y equals 1, 5, negative 2. The slope is 0, which is f prime of x. So you can look at it from a point of view of a graph, which is a horizontal. Definition, plug in x plus h, or plug in x makes no difference. When it's a constant, like 5, like 2, it doesn't change. So the numerator is c minus c, which is 0. The denominator is close to 0, but it is not. It's h. And 0 over any number other than 0 is 0, and the limit is 0. That's the proof by definition. So the derivative of a constant function, d dx of c, equals 0. Reminding you of the compound interest, a is p times 1 plus r over n to the power of nt, where p is the principal, r is the rate, n is the number of times it gets compounded, t is time in years. And so let's say r over n is 1 over m, therefore the reciprocal is m. And if you do the cross product here, n becomes rm. So we can replace this n with rm, and we put the m as part of this and r out. And this gives rise to the compound interest continuously, which has the formula a equals p e to the power of rt. Therefore, this portion, as m goes to infinity, is the definition of a, is the limit of 1 plus 1 over m to the power of m as m approaches infinity. Again, let's make a change. Let's say 1 over m is some variable such as h, then m is 1 over h. As m goes to infinity, h goes to 0. So this limit becomes e equals the limit of 1 plus h to the power of 1 over h as h approaches 0. As you know, e is an irrational number, just like pi. So 2.718, and it continues indefinitely. So when we truncated at 8, it's an approximation. So on purpose, I'm changing n to something else, such as n, as long as this one, and this one are the same, that works. Over here, on purpose, I'm changing the h to x. So e is the limit of 1 plus 1 over n to the power of n as n approaches infinity, or e is the limit of 1 plus x to the power of 1 over x as x approaches 0. And also, we're going to look at this proof, which says e is a number such that the limit of e to the power of h minus 1 over h as h approaches 0 is 1. We'll look at some differentiation formulas and the proofs. One of them is the power rule. The derivative d dx of x to the power of n is n, x to the power of n minus 1, meaning the exponent becomes the coefficient, and then the exponent goes down by 1. So if you apply that to x, you get 1, because the exponent of x is 1. So if you want to go with this rule, it becomes 1 times x to the power of 1 minus 1, which is 1 x to the power of 0. And I hope you know x to the power of 0 is 1, so the answer is the constant multiple rule. This works, just remember, differentiation is the process of taking limits, so it follows the limit laws. So if you have a constant, you can take it out and take the derivative of f of x. The sum rule says the derivative of the sum is sum of the derivatives. d dx of f of x plus g of x is d dx of f of x plus d dx of g of x. And the difference rule says the derivative of a difference is the difference of the derivatives. d dx of f of x minus g of x is d dx of f of x minus d dx of g of x. There's a bunch of formulas. We will concentrate on the first few. For example, the derivative of a constant is 0. X to the power of n is n, x to the power of n minus 1. And according to that, the derivative of kx is k, because k is a number, is a constant. The derivative of e to the power of x is itself. The derivative of sine x is cosine x. The derivative of cosine x is minus sine x. These are the main ones we want to concentrate on. And the rest of them also more, they're all trigonometric functions. The derivative of tan x is secant squared x. The derivative of cotangent x is minus cosecant squared x. The derivative of secant x is secant x times tan x. And the derivative of cosecant x is minus cosecant x cotangent x. As I mentioned, we look at them one by one eventually, and we look at their proofs. We are going to start with the proof for the power rule. F of x is x to the power of n. Its derivative is n x to the power of n minus 1. And the proof always follows the definition. So you don't have to worry about this proof, but if you can follow, you're in good shape. So the limit of f of x plus h minus f of x over h as h approaches 0, you put x plus h, you get x plus h to the power of n here, and f of x is simply h to the power of n. So the idea is that to simplify this fraction, which requires expanding x plus h to the power of n, and to do so, I want to remind you of a couple of things. Number one, the concept of a factorial. N factorial means n times n minus 1 times n minus 2 all the way to 1. 0 factorial is 1. And as an example, 5 factorial means 5 times 4 times 3 times 2 times 1. It's 120. Combination. Combination of n items, choose r, has the formula n factorial over r factorial times n minus r factorial. Binomial distribution uses this information. So when we want to find a plus b to the power of n, this is combination of n choose 0, a to the power of n, b to the power of 0. Plus, now n remains the same, and the numbers add, they add 1 to it. So combination of n choose 1, combination of n choose 2, all the way to combination of n choose n. A to the power of n minus 1, b to the power of 1. Notice the sum of the exponents in all cases must be n. Furthermore, we show that combination of n choosing 0 and n choosing n, both of them are 1. This becomes n, and the rest of them you work it out. And by the way, obviously this means a to the power of n because b to the power of 0 is 1. And this means b to the power of n because a to the power of 0 is 1. Couple of simple examples that you all have seen. Really, they follow binomial theorem, that is a plus b quantity squared is a squared plus 2ab plus b squared. A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Really follows that, or you have to expand it. It's not a big deal. You have to do it 3 times, but when this exponent becomes larger and larger, it becomes more difficult. Now, let's look at n0, for example. Following this formula means n factor over 0 factor n minus 0 factor. So this is 1. This is n factorial, so we get 1. What about n1? So we showed that these two are 1. Actually, we showed one of them. This one, I highly recommend you do it yourself. Okay. Now, over here, we can replace the n factorial with n times n minus 1 factorial. These two cancel each other. We get n. So the second piece is n. And we're going to use those. So when we expand this one, becomes x to the power of n plus n x to the power of n minus 1h plus n choose 2x to the power of n minus 2h squared plus, again, the one before that is nx x to the power of n minus 1, and the last one becomes h to the power of n, and this remains. These two cancel each other. In the numerator, everything involves h. So we can factor the h out. When I factor the h out, I get this one here. This becomes the same thing times h to the power of 1. This becomes the same thing, h to the power of n minus 2. And this one becomes h to the power of n minus 1 because we take out one of those h's. For example, this has originally h times h. How many times? N times. These two cancel each other. So we write the rest of them. And notice every term has h. This has h, this has h, all the way to this one. What doesn't? The very first term. Therefore, that's the only term that remains because everything goes to 0. And that's a proof. So this is what's left. That's a proof that when f of x is x to the power of n, f prime of x is n x to the power of minus 1. Again, you're not responsible for the proof, but if you can follow it, it makes it easier to understand definitions. Again, we are going to look at the easy process by using the power rule. So this one, 6 sits in front, and it goes down by 1, 6x to the power. This one, 1000 becomes the coefficient, and you take off 1, y prime is 1000, x to the power of 999. For this one, 4 becomes the coefficient, you take off 1, 4t cubed. Now, the thing I want to add, y prime, and that's fine, Because the independent variable is t, I like to remind you dy dt is telling you which variable is the independent variable. So the same as dy dx, for example. Okay, and now for this one, we keep the 3. So we write down y prime is 3. R squared is 2, r to the power of 2 minus 1 or 6r. Now, why am I writing the rest of it? Again, I want to show you different notations. Y prime, dy dr, in this case, r is the independent variable, ddr of 3r squared, and the answer is 6r. This one, f prime is 10 times 6x to the power of 5, or 60x to the power. So we're going to do one by one. X to the power of 8, 8x to the power of 7. 12x to the power of 5, we multiply these two, we get 60x to the power of 4. We multiply these two, we get negative 16x cubed. Multiply these two, we get 30x squared. We take the exponent down by one notch. And this one follows this. The answer is negative 6. And of course, any constant, 5 or any other number makes no difference. It's 0. So you're done. Well, the first one is very simple, just 5x plus 1. This gives you 5, plus 1 gives you 0, just 5. But what happens here, the way it's given, you cannot use the power rule. You have to do your algebraic technique to change them to a format that power rule can be used. So to do so, I want to remind you of exponential rules when a is not 0 and b is not 0. For example, a to the power of 0 is 1. A to the power of m times a to the power of n is a to the power of n plus n, and so forth. And you really should be comfortable with all of them. So the thing I want to look at is the following: negative exponential rules. If you have a negative exponent, it goes down, becomes positive. If it's down with a negative exponent, comes up, becomes positive. So this is 2x to the power of negative, which is purely an algebraic step. So we are using an algebraic step, everybody. So f prime is 2 times negative 1, x to the power of negative 1, and we subtract 1. And this, everybody, is, I'm going to put the asterisk next to it, is the only calculus step. So it becomes negative 2. Well, I have that step for you. So it becomes negative 2x to the power of negative 2. Algebra, algebra. Take it down, negative 2 over x squared. Everything consists of algebraic step, with just one exception. And this one just 7 times 2, 14, x to the power of 1, or simply 14x. 4 is a constant. Gives you 0. What about this one? The way it's given, we can't use the power rule. We are going to distribute, and before we do that, square root of x is x to the power of 1/2, everybody. So first, we use the fact that square root of x, x to the power 1/2. Then we use the product rule. X has exponent 1. When you multiply it by this one, you get x to the power of 1 plus 1/2. So that means this is x to the power of 3/2. This is 5x minus 2. So that's purely algebraic steps. So we did just 2 steps of algebra. And now we are going to do a calculus. F prime of x is 3/2. X to the power of 3/2 minus 1 plus 5. Of course, 3/2 minus 1 is 1/2. And x to the power of 1/2, we put it back in the same format, square root of x. So the final answer is 3/2 square root of x plus 5. What is the derivative of pi squared? Please understand pi squared or pi or e or 2 or 1/5 or 10,000. They are all numbers. The answer is you. F of x is 1 over x to the power of 5. Use the negative exponential rule. We move things around. In this case, we bring it up so it'll be ready to use the power rule. So that is the algebraic step. F prime of x is minus 5. X to the power of minus 5 minus 1 minus 5 x to the power of minus 6. We take it down, we make it positive. And again, this was the only calculus step. Part B, f of x is 2 over 7x cubed. You move this up, make it ready for the use of the power rule. So 2/7 x to the power minus 3. F prime is 2 over 7 times negative 3. X to the power of negative 3 and subtract 1. You get negative 6 over 7. X to the power minus 4. X to the power minus 4 moves down. So we get f prime of x is -6 over 7 x to the power of 4. Again, look at the only calculus step 1, 2, 3 algebraic steps. This is the only calculus step. Part C is not ready for the power rule yet. So we use this quotient rule. This one, and this becomes 2 over 9 x to the power of 5 minus 9, which is 2 over 9 x to the power of -4. And now f prime is 2 over 9 times -4 x to the power of -4 minus 1 is -8 over 9 x to the power of -5. You take this one down, minus 8 over 9 x to the power of 5. In the final answer, you can't have a negative exponent unless the question is given with the negative exponent, then you can give it back with negative exponent. Again, notice calculus step. Everything else was algebra. I hope you remember we changed square root of x to x to the power of 1/2 in the previous page. And so now it's ready. F prime is 1/2 x to the power of 1/2 minus 1. 1/2 x to the power of -1/2. 1 over 2 x to the power of +1/2. 1 over 2 square root of x. Again, just one step of calculus. For part E, we change this to an exponential format according to that rule, 2x to the power of 4/5. F prime is 2 times 4 over 5 x to the power of 4 over 5 minus 1. 8 over 5 x to the power of -1/5. 8 over 5 x to the power of 1/5. Put it back, 8 over 5, the 5th root of x. For part F, later on we learn about the quotient rule. And you shouldn't use the quotient rule because there's an easier way. You make up two fractions, everybody. This fraction gives you 10. This fraction gives you -7x. And the answer is simply -7. There is no need for the upcoming quotient rule of differentiation. And that's the idea, everybody. All right, class, we want to find the equation of a tangent line. So we differentiate, we get 2x minus 3. We need to plug in the 4 into the original function to find the pair x comma y into the f prime of x to find the slope. So if we plug it in to the original equation, we get 4 squared, which is 16, minus 3 times 4, which is 12. 16 minus 12 is 4, minus 1 is 3. And if we plug in 4 into this, we get 2 times 4 minus 3 is 5. So we use y minus y1 equals n times x minus x of 1. We distribute. We move the negative 3. And we get y equals 5x minus 17. Again, whenever you put the pair x comma y in, that means, and it works, means we haven't made a mistake with this process, doesn't say anything about that. Find the points for which the tangent lines are horizontal. Tangent lines means differential. 3x squared minus 6x. Horizontal means the slope of a line is 0. So set this, because this represent infinitely many slopes for tangent lines. So set it equal to 0. To solve this, take the 3x out. You get x minus 2. So x is either 0 or 2. Sometimes you can stop there and that's the answer. Sometimes they want the pairs. So if you plug in 0 clearly, you get 0 here, and that gives you 5. If you plug in 2, you get 2 cubed, which is 8, minus 3 times 2 squared, which is 4, times 3 is 12. 8 minus 12 is minus 4, plus 5 is 1, and you get the pair 2, 1.